Dear students, we learned in the previous module that algorithm representation could be ambiguous, and we defined that we need some primitives which are understandable by everyone in the world, that what they mean. So in this module we will talk about primitives with some examples from different domains. So algorithm representation, the representation of an algorithm requires some language. In case of human, what you know, the human have a language: English, German, Urdu, Punjabi, Pashto. So all of those languages are available for human. However, when they communicate, even then we have some confusions. For example, I will give you an example, like if I give a statement, visiting grandchildren can be problematic. So this might have two meanings. One is that when grandchildren visits you, that is problematic, and the next meaning could be that when you visit your grandchildren, that is problematic. So this means even the language human speaks, they could have a ambiguous meanings, and if computer could have such ambiguous meaning, then algorithm defined by one person could produce different results when represented in one form and could produce different results when represented in another form. So here is a representation where we want to fold a page, a square page, into a bird. So here you can see that we are using different symbols. These are called primitives. For example, this arrow sign, this sign, this is another sign, this is another sign. They all have different meanings. So for example, this means that you need to fold this paper in this way. However, when you say this thing, then you are saying that this thing need to be reversed and the surface which is not shown in this picture should be available in this picture. So all of these constructs, the primitives, are being used by some students which are called orgonomy students. So this orgonomy students and their art, we will little bit more learn in the next slides, that this is an art of Japanese. This is a Japanese art of making pictures using paper. So at the moment we are saying that the information which we have represented over here can be understood by the student of origami who have little knowledge about what are the primitives and what does it mean. However, these symbols cannot be understood by someone who is not a student of origami. So in computer science, we want to make such primitives which are understandable by everyone. So computer science establishes a set of building blocks from which algorithm can be constructed, and each building block are known as primitive. And a programming language in which we will write our code, in which we will represent the algorithm which we have defined, is a collection of primitives. So it will have the primitives, which means some important thing, with the collection of rules stating how the primitives can be combined together to represent more complex ideas, constitutes a programming language. So this is basically the concept of programming language from primitive. So each primitive has its own syntax, symbol, and its semantics, the meaning. We will be talking about computer science primitives in next modules. However, here we want to just have some generic examples to show you that what are the primitives and what are their meanings and what are their representations and what are their semantics. So for example, if we see this diagram of origami primitives, it has some primitives like this one, the syntax is here and the semantics is here, that whenever you write this thing, this means turn paper over as in, like this. So this is shown with an example. Then it is, for example, saying that when we have such a symbol, it means represent a valley fold so that this represent this one, like a folded book. So every primitive defined over here in a syntax have semantics which are defined over here. So these are the primitives of origami. However, we will learn about computer science primitives as well in details in the next module. So our ultimate objective is the representation at machine level. So you know that we want to actually represent each step at a machine level, because computer only understand the language of 0 and 1. However, it is tedious to convert each of the instruction by ourselves into the machine code. So we have defined high level programming languages which have primitives and set of rules that have been built. Mapping primitives to machine level instruction is the next step. So we have high level language, and then high level language is converted into machine level language. So this means all of the constructs or the primitives defined in the programming language should have a clear meaning so that it can be converted into exact and actual machine level instruction that is going to be executed by the computer system. So if we summarize today's module, we have learned about primitives, programming language, origami, art of Japanese folding of paper and making pictures, and then machine representations.